You guys will run out, and I'll sit there. Check my email, I guess. Okay, so here's a nice shoot. This is Northern California. This is one of these drive-through trees in Northern California. This is a massive shoot, one of the more impressive shoots. In the 1930s, they cut holes into some of the trees up there. There's 3 of them still in existence, and you can drive your car through them. Actually, I think they might have closed them off now, but they're still there. And we'll talk more about kind of the edges of that next time. But this is a chute that you can drive through, and the tree looks like it has trees on itself. So they call it the chandelier tree is the big one. And the branches on it look like bigger than normal trees. This is giant. You can see it there. Giant redwood. Beautiful trees there. An impressive shoot. True or false? Shoots contain stems and leaves. What do you think? True. Shoots are the above ground portion of the plant and are anatomically the same as roots. The first part is true. They're the above ground portion of the plant, but they're not anatomically the same as roots. They have a slightly different anatomy than the root system, which we'll talk about here today. So the shoot, the above ground portion of the plant, consists of the stem and leaves. There's a little crocus plant to show some of that structure. The stem, the above ground axis of vascular plants. Non-vascular plants we don't really refer to them as having stems, so think of things as vascular. The leaf is what we call the principal lateral appendage of the stem. So lateral means it comes off the side. So the principal lateral appendage of the stem. And it is sometimes called a foliage leaf or a photosynthetic organ, although most botanists cringe when you say the word organ and refer to plants, but some textbooks will use that term, organ, because organ to an animal person is something very different. But typically the thing is photosynthetic, the leaf. We do have modified leaves, which we'll talk about at the end here. There are modified leaves which are not photosynthetic. They typically take on a protective type function, protection against being eaten by some animal. The different parts of that shoot system, we've got what's called the node, part of the stem where one or more leaves are attached. So where the leaves come off is the node. Node, 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 node. Inter means between. So if you say internode, that's the region between the nodes. So here's a leaf, so that's the node. The region between that would be the internode, followed by another node. Node and internodes. And then we have buds. Some sort of embryonic shoot protected by young leaves, and typically the buds are at the nodes, and they're in the axils. Typically the buds are, like you see up here, they're in the axil, which is the armpit of the leaf that you see there. So over this way, here's the bud in that axillary region you see. So this is a repeating unit here. This repeating unit of those components there, the repeating unit is called a phytomere. That's the repeating unit that we have in plant stem. We can say shoot, stem / shoot. It's called a phytomere, which means plant numbers, as it goes over and over and over again, repeating through that portion there. And here's that repeating unit. It's cut off over here. So it says phytomere here in the middle right. So you can see it says axillary bud, internode, node, leaf. So those are the repeating units to that. We get the leaves coming off at all those nodes. We got internodes and we have buds that form. Over on the left is a real plant here. This is showing you what it looks like. We have a shoot apical meristem, which we talked about before. You can look at it today. That shoot apical meristem is what contains the three primary meristems. So, what are the three primary meristems again? Protoderm, ground, and procambium. So, there are protoderm, ground, and procambium, or procambial initials in the apical meristem there. And so that's a very highly active, highly dividing, fast dividing region of the plant body, because that's where all the shoot, that's where all the stem tissue is going to come from. And it's coming from those initials, from those three primary meristems right in there. And they're going to make this, which is the leaf. Here it is here. This is the leaf that you see there. And they're going to make these buds that are there as well. What's a primordium again? There it is. I like to call it a structure these days. The book calls it a leaf or bud in its early stage of differentiation or development. I like to call it just a structure because then you can talk about a root primordium. We can talk about a leaf primordium, a bud primordium. Talk about whatever structure, a flower primordium. So a structure in its earliest stage of differentiation or development. So that's what these are. These are leaf primordia and young leaves. Is really that's what the fancy term means. So let me point out one more thing, because you're going to look at it. This shoot apical meristem is called the tunica corpus. So this means layered body. And so what you're going to get is something like this. It's not really. But right in here, this is your tunica corpus. Right in there. And so, like I was just saying, that's where all the meristematic activity is going to occur. That's where all the cell division is going to occur. So that tunica corpus contains the initials. Of the primary meristems. And therefore, it's that tunica corpus where all the new cells and therefore tissues of the plant body of the shoot system are going to be made. There's two regions to that, which you can also look for in the lab. There's a central region called the central zone. And then I did it here on purpose, these other cells on the outer edge, which divide a little bit differently. These are in what's called the peripheral zone. We're not going to go into details of that development, but this tunica corpus does have a lot of very actively dividing cells that are protoderm, procambium, and ground initials. And they're in that central part, but also on the edges, which is called the peripheral zone, or the peripheral part to it. So the whole thing is actively dividing, and it's in layers. It's hard to see here. I don't have a picture of it, but it does form layers, and that's where the tunica comes from. Okay, so I've been dancing around this for some time now. I'll go here. These are easy to match up. I've been kind of dancing around this for some time about the three types of steels that are found in plants and where they're found. So this is the time that I get to draw these up on the board for you. So we've been talking about the protosteel. We've been talking about the siphonosteel. We've been talking about U-steels a little bit, kind of off and on for the last 3 weeks or so. We got into the seedless vascular plants. So what I'm going to do next is actually outline these. And actually this one here is a version of this one. So this is a modified version of what's called a U-steel that you see here. So I want to outline the three types of steels for you, and then I'll come back to this here in a second. So if they say steel, they're referring to the vascular arrangement in a stem or in a root. Is this okay? What's that? So the most simple type of steel is called the protosteel. And the protosteel, what you're going to get there is in the center, we got a central column. So these are the three main types of vascular xylem and phloem arrangements. In the center, we got a bunch of xylem. And typically it's surrounded by some phloem. But it forms a central column. That's what a protosteel is. And then, so let me label those here for you, that way you know what they are. So red is xylem. And blue is the phloem. And then what's all this stuff here that runs from here to the outside? What do we call this stuff? This is called the cortex. Those are parenchyma cells in the cortex. So this is a bunch of ground tissue. So all that stuff, these are the parenchyma cells in the cortex. That's really what they are. That are there. So that's a protosteel. That central cylinder of xylem and phloem. So the question is, where do we find this type of vascular arrangement? We find it in Lycopodiophyta. We find it in gymnosperm, roots, and we find it in eudicot, roots. That's where we find that type of vascular arrangement, so to speak. Okay, so the second, so the protosteel is the most primitive. That's the first type of steel that evolved. The second that came along is we get a siphon or a ring of xylem and phloem. We get a ring of xylem and phloem. Same color coding as before. And in the center of that little ring, we've got what's called the pit. That's the region. So this region is called the cortex. The center region here with the ground tissue in it, with the parenchyma cells, we call that the pit. So in here, we've got a bunch of parenchyma cells. This is called the pit. And it's, there you are, a bunch of parenchyma cells. We've got a ring there. We also have a cortex too. So there's a cortex, again, made up of more parenchyma cells that go all the way to the outside like that. So there's parenchyma cells or ground tissue in the pit, but also in the cortex again. It's called a siphonosteel or a siphon. And we find this in some Monilophyta. Ferns is typically where you find it. Some Monilophyta, which is typically ferns. find this in gymnosperm shoot system. You find this in the monocot root system. Some vanilla phyta, gymnosperm shoot, monocot root, and some eudicot shoot system. Not all, some. So the protostele isn't up here. It's not up here, but if you look at the siphonostele, here it is here, the basketwood, but then up there you see it, there's the pith, there's the vascular cylinder, which is the name for the xylem and phloem, and then there's the cortex, which is the parenchyma cells. So that's where we're at. Again, the protostele is not up here. And the reason for that is there is no protostele that occurs in the shoot system. We just these are our examples we have here. The final one is called the U-stele. EU. Our most advanced type. U means true. And what you get here is you get these vascular bundles. I'm going to show up there. You get these little packages of xylem and phloem in a ring. They're in a ring, but they are separated from each other. There's the xylem. There's the phloem. Kind of like that. They're still in a ring, except that they're discrete. They're separated here now. So they call those vascular bundles. And we've got a pith. I guess I can put that in too. We have a pith, so this is full of the same parenchyma cells. And then they make their way out to the outside here and all the way around. You can see those colors there. So there's our pith again. We do have a cortex, and there's our xylem and phloem, our vascular bundles that we have here. I'm going to go ahead and put it here and call it equisetum, the horsetail. Equisetum has a U-stele-like stem, but I don't know if it's a really U-stele, but that's kind of what they call it. So we'll sort of go along with the flow that you have there. So it's equisetum, and then we get eudicot, some eudicots. Shoots. And then this one here is actually a version of this, but as you can see, this one's called scattered. So I tend to leave it off of there, even though it's kind of a version of it. So really, you've got the protostele, the siphonostele, and the U-stele, And you got different versions of these, but this is, I think, a nice, easier way just to kind of put it. We'll kind of leave it at that. So this one over here is a monocot, and this is called scattered or complex. So I'll make that note off to the side for you. Monocots have what's called scattered or complex. Vascular arrangement in their stem. Well, like I said, yeah, it's a subtype of an actual yeast deal. So that's scattered, that's complex, it goes throughout the stem in corn, so you can identify a monocot just in cross section. Here's that yeast deal, which you'll look at in lab, alfalfa, big pit. And then there's the vascular bundles with the xylem and phloem, which you probably can make out the xylem with the big round cells that you see there that they're pointing out. Now you can see why I didn't want to do that. This takes a lot of time, huh? So depending on which plant you're looking at, its shoot or its root system, you're going to see different arrangements of vascular tissue, and that's kind of what's how those things are organized. Typical examples of those. Okay, so we're going to go ahead and move on, and I'm going to give you some further examples of some stems. This is a part that's maybe worth paying a little more attention to here, although I don't think we have any tendrils on campus. Right. I don't think I send you out for any, but here's some definitions for you, some modified stems. So a tendril is a modified leaf that spirally coils and holds on, so it's a structural support type thing, a tendril. So if you think of a grapevine, a tendril that is coming off there, that tendril is a modified leaf. It's green, so it's photosynthetic, but it's slender and its function is to hold on, provide support. Stolons, these are also called runners. These are stems that grow horizontally on the soil surface, often giving rise to new plants at the nodes. Anybody got an example of stolons?
Grasses.
Some grasses would produce some stolons. Yeah, sure. Strawberries, a good one. Pumpkins, yeah, sometimes they kind of people on the bottom and put up. Yeah. Anything that's on the surface and kind of going sideways. That's a stolon. Thorns, hard, woody, sharp-pointed, modified stems. They arise from the axils of leaves. So for it to be a thorn, it has to be hard and woody and to come from the axil or the armpit of the leaf. So this is not roses. Roses don't have thorns; they have prickles. A thorn is something like, if you haven't ever seen one before, if you've ever been around a citrus tree, citrus trees have these big honking thorns there, and if you ever seen those, yeah, you don't want to put your hand through that. They're very hard and I'll say spiky. Then we got spines. So hard, woody, sharp-pointed, modified leaves are spines. So something like a cactus. Those spines on a cactus, those are spines, and those are modified leaves for protection. So these are for holding on. These are for protection. These are for protection too. And finally, the prickles, which are also for protection. They're just little epidermal derivatives, means they come from the epidermis. They're not really connected to the vascular system. But they are pointed, sharp pointed. I think the only one I asked you to go get on campus is the prickles today. Because you know where those are at, right? The roses. I don't think we had those other ones. Okay, so true or false, this is a tendril. That's true. So this is grapevine. Usually what you see with grapevine is you get the foliage leaf, which is the photosynthetic leaf on this side, and then the modified leaf is here. So that's a leaf, It's a modified leaf. It's for holding on. And it curls because of auxin. There's a hormone in this plant, and the hormone goes to one side of that little tendril, and it causes the cells on this side to elongate. And if these cells all elongate, and the other ones stay the same size, it causes it to curve. So it's a hormone caused thing. True or false, this is also a tendril? It's false. So this is your stolon, this is your runner. So this is the internode. There's the node. So when you come to a node, you're going to have leaves and you're going to have roots come out. So this is a little asexual reproduction. You can have a little runner here, the internode, and then that's where the node's going to be. You can see them how long they are. Do you want these in your strawberry plants? No. And why is that? Because there's a mom. Go ahead. Yeah, they take away your nutrients. So if you want to eat a bunch of unripe strawberries, yeah, then you want this. So what happens is there's a plant over here which is giving nutrition to this little satellite plant here, rather than putting that nutrition or carbohydrates into the fruit. So you want to cut these off. Typically that's what's done because these plants are going to take some nutrients from mom over here, the mother plant, and then the mother plant gives them that rather than putting it in the fruit. So you end up with a bunch of immature acidic fruit. You want to cut those things off. The following is a hard, woody, sharp-pointed, modified stem that arises from the axils of leaves. True or false, this is a spine. So that would be false. This is what a thorn looks like. This is hawthorn. Hawthorn is typical thorn you see there. The thorn always comes from the axil, which is the armpit of the leaf. These are spines, so cactus, the typical spines. Again, those are for protection, anti-herbivory. They keep animals from wanting to eat that because that doesn't taste good in your mouth. This is actually the shoot apical meristem. So cacti are funny in that this whole thing here is the shoot apical meristem. It runs along a ridge. So you see this region between here and here? That's the internode. So that's the node where the leaves come off. These spines are leaves. So that's the node, that's the internode. There's more leaves or spines. So that's the node, that's the internode. So it behaves a little bit like a typical plant there. Here's your prickles. And you can pop them right off. You just push on them, they pop right off the skin. They're on the surface there. The thorns are not. The thorns have vascular tissue running all the way in. There's some underground stems. A rhizome is an example of that. So a horizontal stem that grows out or below the soil surface. We have tubers. So if you wondered about the potatoes, we didn't talk about it, you thought the potatoes should be in the root system. They're not. They're enlarged, short, underground stems. They form at the tips of the rhizomes. That's what this is. Potato. Bulbs. These are shortened underground stems covered by enlarged, fleshy storage leaves. So if you've ever opened up onion or garlic, there's juice inside of there. It's very fleshy. When they say fleshy, it means juicy inside of there. So if you cut that open, you get a bunch of juice inside of there. That's a true bulb. The corm is different. So here's a corm. A corm is like gladiola or crocus plant. They have thickened underground stems, but the leaves are small and papery. So they don't have that extra fleshiness that we think of as onion and garlic. I don't think I asked you for these to get on campus because I don't think we have those on campus. We have some rhizomes, but they're a little hard to find. So here's some pictures. Most people have seen garlic and onions before. There's the fleshy leaves inside of there. Here's our tubers. They're at the ends of these rhizomes, which is coming off the stem. There we go. Anybody ever grown potatoes? So that's one of the more exciting things to do in life. If you have a potato in your fridge that's just sitting there, look on it, see if it has eyes. Those eyes are the shoot system, they're starting to grow. You can cut off all those eyes into different quadrants and then plant those. Now's a good time, actually. You cut those off of there and you plant all those, and the eye will start to grow and form a shoot come out of the ground. All that carbohydrate, which is in the other part of the potato that you planted, that'll be used for growth. So you just put them in the soil, just give them some water, and they'll go ahead and germinate out from those eyes. And when you pull it up, it's like catching a fish, I think. You're surprised that it worked, and you caught something. When you pull up that potato plant, you're like, what? There's all these things hanging from it. Potatoes, and it's fun to eat. So, here's your papery leaves, there's your point. This is important for you for the lab here for your scavenger hunt, is that you're going to be looking for these types of leaf arrangements. When we talk about these 4 types, we refer to these as phyllotaxy. So that means leaf arrangement, is literally. And we have what's called basal leaf arrangement or phyllotaxy. That means the leaves, like in monocots, some monocots on campus, the leaves go all the way to the ground. That's called to the base or basal. So you're going to be collecting this, basal type phyllotaxy. You're going to be looking for opposite. The leaves at the node are coming off on opposite sides of the stem. If they're right opposite of each other like that, that's opposite. Alternate phyllotaxy, go look for that one too. There's a leaf on this side, then the leaf goes on that side. Then it goes back on this side, then it goes back on that side. It alternates from side to side. And the final type is called whorled. And we only have one of those on campus. And so I'm not going to have you look for that, but I still want you to know it. At a node there, you're going to have leaves coming off in a circle. So 3 or more leaves at a node in a circle around the stem. We do have equisetum on campus, but not many people know where it's at or could find it. And so it would be just torture for you guys. Okay, so basal, opposite, alternate, whorled. You're going to be looking for all 3 of those. Burn that into your brain. Anybody know what this is, by the way? I think some of you collected it. Lily of the Nile. It's got like a white or purple flower. That's the typical pretty good basal. Also, we collected over there, one of the first things we collected was formium. It was growing out of the ground. Big long leaves, don't fit on the paper. That's a monocot, that's typical basal.